notes for AP Calculus on the topic of related rates, part 1, continued. So, this one we've got a diagram. Sometimes you have to draw it yourself, sometimes it's given to you. And I accidentally forgot the word A right there. So it says a circle is inscribed in a square, as shown in the figure above. And then it tells you the circumference of the circle is decreasing at a constant rate of 12 centimeters per second. So, since it's decreasing, that tells us it's a negative rate. And in this case, it's giving us the rate of change of circumference, so that's dc dt would equal negative 12. So that's the rate we know. And then it says, as the circle contracts, the square contracts to maintain the condition of tangency. In other words, at these 4 points, the square is tangent to the circle here, and that's going to stay true. So it's going to still look like this, even though it's a different size as it gets smaller. Then what we're asked to find, the rate we're looking for, is the rate at which the perimeter of the square is changing. So we're trying to find dp dt. And then indicate units of measurement. Alright, so a lot of these problems you can get an equation that relates these two. It's hard with the perimeter of a square and the circumference of a circle. But what we can do first is remember to label your diagram. And anything that involves something circular, you pretty much always want to use r as one of your variables. There's the radius. And remember the circumference of a circle is 2 pi r. That'll be where we use dc dt. But we're trying to find the perimeter of not the circle, the square. So that's what the circumference is. It's the perimeter of the circle already. We want the perimeter of the square, so we want to use as few variables as possible. And notice since that's r, that would be the radius there also. So from here all the way to here would be r plus r2r. And since it's a square, this would be 2r, this side of the square, this side would be 2r, and so would this side. They're all the same. So the perimeter, we need that equation as well. So the perimeter here would be 2r plus 2r plus 2r plus 2r is 8r. And since we're looking for dp dt, let's try to take the derivative of that one first and see what we get. So we take the derivative of p, that gives you 1, but then the variables don't match up with implicit differentiation. So then that gives you dp dt. Equals derivative of 8r is 8, but again the variables don't match up, so you need to multiply that by dr dt. So notice, in order to solve for dp dt, there's one missing piece of information, dr dt. Some problems they might give it to you, but here they don't. They give us dc dt. But that's where we can utilize this equation, the circumference. So this is one where you need two different equations when there's not one that easily relates your two variables in the rates you're given and the rates you're looking for. So the derivative of c, well, there's our dc dt, equals the derivative of 2 pi r, which is 2 pi, and then we need dr dt. So from there, we can substitute in dc dt, that's what we're given as negative 12. Equals 2 pi, and then dr dt is what we're looking for. So then to solve for dr dt, you just divide by 2 pi. And we get dr dt, negative 12 over 2 pi reduces to just negative 6 over pi. And then we can substitute that in right here. So we'll have dp dt equals 8 times negative 6 over pi. And you can see that gives you negative 48 over pi for our final answer for dp dt. The rate of change of the perimeter of the square. And then these are almost always going to give you the units for these. So to find out the correct units, remember you just look at the units on the numerator. The units for perimeter, well, that's just a length, that's one-dimensional. So that would just be centimeters. And the units for time here are seconds. So centimeters per second. And we got a negative answer because circle was contracting, right? So that's going to make the perimeter of the square also get smaller, contract. So we should have a negative answer. All right, let's take a look at the same overall problem, but part B asks for something a little bit different. It asks to find the rate at which the area of the square is changing. So we were trying to find in part A the rate of change of the perimeter of the square. Now we're trying to figure out the rate of change of the area of the square. And I apologize, I accidentally left off an important phrase, and that's, so you can just add that in there. It should say in terms of the radius of the circle R. Which means we're not going to get a specific number like we did in part A. Our answer is going to have R in it. Okay. All right, so because we already figured out some information in A, that's going to make part B a little easier. So we'll start off with the area of the circle formula. Area is pi r squared. And since we're looking for dAdt, you would take the derivative of that with respect to time. So that would give you dAdt equals 2 pi r and then dr/dt. Now, if we hadn't already done part A, we'd have to do the same process to find dr/dt using dc/dt to figure it out. But since we already did that work in part A, there's no need to do that again. We already know dr/dt is negative 6 over pi. So dAdt equals 2 pi r times negative 6 over pi. Then notice the pi's reduced out there. And you get negative 12 over pi. Let's see, I think I did something wrong here. Let's see. Oh, sorry. I wrote the wrong formula. The area of the square is changing. My bad. I actually wrote down the area of the circle formula. So let's modify that here. I don't have to erase everything. But I forgot the area of the square, not the circle. So the square is 2r and 2r. So it'd be 2r times 2r, so it'd be 4r squared instead of pi r squared. Which means the derivative would be 8r, right here. And then instead of 2 pi r here where the pi's cancel out, we've just got 8r right here. So yeah, so just be careful, I accidentally wrote down the wrong area formula. I was finding the rate of change of the area of the circle, and it said the area of the square. All right, so now we can multiply the 8r times negative 6 over pi to get dAdt is negative 48r over pi. So it kind of looks like the answer to part A, but there's a big difference because there's an r in it. Okay, so if we knew what r was, if the radius of the circle was 4 centimeters, you would put that in for r and you get that answer. And the units are a little different too because now it's the rate of change of area. And area is two-dimensional, so instead of centimeters, it'll be centimeters squared per the units for time here are seconds. And again, we get a negative answer because the area of the square is also decreasing as the circle contracts here. All right, let's take a look at one more example with, again, a couple parts. So this one, it says 2 boats are traveling across a body of water. And just to make sure we set this up correctly, it's going to give us some directions here, so I'm just going to draw a little directional indicator to make sure we're all on the same page with the directions, just like we would have on a map here. We got north, south, east, west. All right, so it says we've got the boat named Vitamin C is traveling due east towards the harbor at a rate of 10 kilometers per hour. So, and then we've got another boat here named the Codfather is traveling due north away from the harbor at a rate of 16 kilometers per hour. Okay. So one boat's traveling north away from the harbor, one boat's traveling east towards the harbor. So to set this up, let's draw a diagram here. I can't really draw a harbor very well, so I'm just going to write the word harbor. And Vitamin C is traveling due east towards the harbor, so that's going east. And so I'll put the little boat right here. East towards the harbor. And because we're given that's moving due east towards the harbor at a rate of 10 kilometers per hour, I'll assign a variable here because that's how this is changing. And you can use whatever letter you want, but just to remind myself which boat it is, I'm going to use capital V for Vitamin C. And then the rate of change here is given dv dt. So unlike the other problem where it just clearly stated that it's decreasing, sometimes you'll just have to look at the diagram to see if the rate should be positive or negative, based on whether the distance, in this case, is increasing or decreasing or whatever it is. So since the boat is traveling east, notice v is getting smaller. So dv dt would actually be negative 10. Versus if the boat was traveling west, then v would be getting larger, and it would be a positive 10. We can use that same reasoning for the other boat. So the Codfather is traveling due north, it says, away from the harbor at a rate of 16 kilometers per hour. So here's the Codfather boat here. And I'll just use capital C to remind myself which boat that is. And notice, since it's moving north, away from the harbor, C is getting larger. So dc dt would be positive 16. Notice if it had been heading south and C was getting smaller, then it would have been negative 16. So it all depends on the setup there, in terms of whether the variables are getting larger or smaller. And then what we're asked to find is the rate of change of the distance between the two boats. So we have to draw that in our diagram. Here's the distance between the two boats. You can call it whatever you want. I'm just going to use x for that. So based on that, we're trying to find dx dt. And then specifically when the Vitamin C is 12 kilometers from the harbor, so that's where you draw your vertical line here. So when v equals 12. And when the Codfather is 5 kilometers from the harbor. Oh, excuse me. So C equals 5. All right, so now we need an equation. Unlike the other problem we did, this one, there's one equation we can use that would relate all three variables. And that, in this case, you can see it's a right triangle. Let's let the diagram there. So we can say b squared plus c squared equals x squared. And then take the derivative of that with respect to time to get our rates in there. So the derivative of v squared is 2v dv dt plus the derivative of c squared is 2c dc dt equals the derivative of x squared is 2x dx dt. And then once you take the derivative, that's when you can start substituting in what you know. So now v, now we can put in the 12 there. Remember these values here, 12 and 5, you only put in after you find the derivative, not before. If you put them in too soon, before you find it, then you're treating them as constants, as if they never change in the problem, which is not true. And then we've got plus 2 times c, which we are told is 5. Oops, I forgot dv, sorry about that. dv dt we know is negative 10. Plus 2 times c we know is 5. And the c dt, we already know is figured out as 16. Equals to x we don't know yet. And then the x dt is what we're looking for. So once you substitute in all the information you know, you can see if you're missing any information or not. In this case, we know everything to solve for dx dt except for x. And where you usually go to find that information is back in the original equation. So that's what we're going to do. Go back here. And then, since we already took the derivative, now we can substitute in 12 for v plus 5 for c. To help us solve for x. And then just find the derivative of that. I'll find the derivative. We already found the derivative. Sorry, we just need to solve it for x. All right, so we've got 144 whole squared plus 25 equals x squared. And that gives you 169 equals x squared. And then take the square root of both sides. So normally when you take an even root of both sides, remember you normally plus or minus. However, based on the context of the problem, x is a distance, and distances can never be negative. So in this case, we only use the positive 13, not the negative 13. And then we can substitute that in. That was our one missing piece of information right there for x. And start simplify to solve this. So 12 times 2 is 24 times negative 10 is negative 240. Plus 2 times 5 is 10 times 16 is 160. Equals, when we substitute in 13 times 2, that's 26. And then we've got the x dt. And then you can combine negative 240 plus 160 is negative 80. And then just divide by the 26. So you can reduce that. Those are both even numbers, so you can divide by 2. And yet dx dt is divided by 2, that's negative 40 over 13. And then the units on it. Well, the units for x as a distance would be kilometers. And the units for time, the hours. And now here, unlike the last problem, notice we got a negative answer, which means the distance is getting smaller between them. But both c is moving north, that's making the distance get larger. Both vitamin C is moving east, that's making the distance get smaller. So really on this one is not one you could predict necessarily ahead of time whether the answer is going to be positive or negative. It could have been either. In this case it happened to be negative. It really depends on what the rates are, how large those are, as well as the specific numbers you substitute in for V and C in this case. So this one could have ended up being either one. In this case though, the distance is decreasing. All right, let's look at one more related to this one. Part B here. We've got the same overall setup here, so I'm just going to draw our triangle again. B, just going to put the essential components on it, T and X. And then it asks for the rate of change of the angle between the path the codfather is traveling along and the distance between the two boats. Okay. So we're trying to find the rate of change of the angle between the path the codfather is traveling and the distance between the two boats, so right here. And you can call whatever you want. I'm just going to use theta though, to remind myself it's an angle. So then we're looking for what is the theta dt. And again, specifically when vitamin C is 12 kilometers away and the codfather is 5 kilometers. So that same instant. All right, so here we have actually some different options to get an equation with theta, all involving a trig function. So you could use sine of theta, d over x, cosine of theta, c over x, or tangent of theta, v over c. Any of those would work here, and they'd all give you the same answer in the end, even though the steps are a little different. However, what I'm going to do is treat it as if, because you won't always have done part A first. Here we did in this case, so we know dx dt, but sometimes you might not have already figured out dx dt, in which case, the best choice, if you didn't already do part A, would be to use B and C, which would require using tangent. So that's the one I'm going to use here, even though in this case we could use any of those. So, tangent of theta would equal opposite over adjacent, so V over C. And then we'll take the derivative of that in order to get d theta dt. So remember the derivative of tangent is secant squared. So secant theta, put the square here, but it's a little more so we can put it there. And then we need d theta dt right after that, which is what we're looking for. Equals, and over here, notice we have to use the quotient rule. So the derivative of b dt, derivative times the denominator c as it is, minus the numerator as it is v, times the derivative of the denominator ac dt. All divided by the denominator squared. So in this case, c squared. All right, let's substitute what we know here. So theta we don't know yet. So we'll do this secant theta squared. d theta dt is what we're looking for. dv dt, remember we know that one is -10. C, we know is 5, minus V is 12. dc dt we know is 16. Divided by c squared, or c again is 5, so 5 squared. So we're trying to solve for d theta dt. It looks like we've got everything on the right side of the equation, but it looks like we're missing theta. However, notice with 5 and 12, this is not a 30, 60, 90 or 45, 45, 90 triangle. So you can't easily find theta that way. However, we don't actually need theta. Notice we just need the secant of theta, and that we can figure it out. So we go back to our diagram here. So a lot of times you go back to the original equation. Here we're just going back to the diagram itself, because we want to know what secant of theta is. Well, secant, remember, is the reciprocal of cosine. Cosine would be adjacent over hypotenuse, c over x. So secant is x over c. And we know c is 5, and remember in part A, we figured out x is 13. So it'd be 13 over 5. So if we hadn't already done part A, we'd have to just use the Pythagorean theorem again to solve for x. Oh, and one thing I forgot to point out there is, yeah, you can use the Pythagorean theorem, or you might remember the 5, 12, 13 is one of the Pythagorean triples. So if you remember that, that would save you from having to use quadratic formula. But either way works. All right. Then we can just take this 13 over 5 and substitute that in directly for secant theta right there. So we'll just have 13 over 5 squared times d theta dt. Now let's start to simplify to the right side here. So negative 10 times 5, that's negative 50. 12 times 16, well 10 times 16 is 160. 2 times 16 is 32. So 160 and 32 gives you 192 over 5 squared 25. And then if we square that up, that's going to be 169 over 25 times d theta dt equals negative 50 and negative 182 gives you negative 242 over 25. And then last step, to solve for d theta dt, divide by 169 over 25, which is the same as multiplying by the reciprocal, 25 over 169. So notice the 25 is reduced out there. And negative 242 over 169, to see if that reduces or not, well, just remember 169 came from 13 squared, right? So it's 13 times 13, and does 13 go into 242? No, it does not. So that's how you know it doesn't reduce any further. Notice we got a negative answer, which means the angle is decreasing. And the units here are a little bit trickier because they don't give them to you in the problem, you have to know them. Well, with an angle, well, we have two major units we use to measure angles, degrees and radians. But degrees are kind of their own separate measurement. So unless the problem specifically mentions the units for the angle are degrees, radians are just numbers. Even though we usually write them in terms of pi, they're really just regular numbers. So since we have just a regular number here, the units for the angle would just be radians. And the units for time here are called hours, so radians per hour. And that concludes the notes for AP Calculus on the topic of related rates, Part 1 continued.